we've decided that in today's class we are going to specifically talk about how to compute time and space complexities and what are the different ways and some popular tips and tricks out there. Okay, so to start with, I'll be talking about these things. Okay, this class of thing where you talk about time and space complexity of any problem, this is also called as asymptotic analysis. However, this is a very mathematical term and this has got many mathematical symbols and their definitions. No need to dive deep into that. We should just know the practical aspect of these, okay? And we should be very comfortable that given a particular problem, we should be able to come up with the right complexities without confusion, okay? So, let me ask you one simple question. How will you represent the running time of a code? Okay, as simple as that. So the question says that you have a code which is written, okay, and that code takes some time when it runs. Let's say the code is to sort an array. If let's say it has taken 2 milliseconds to do that, you might say that the run time is 2 milliseconds. So that is one way to represent the run time in terms of the unit of time, which is second, milliseconds, minutes, whatsoever it is. So two of you are saying that we should represent it based on input, we should represent it based on operations, as a function of input. Okay, great. So I think three of you are talking about input, and I believe by input you mean the size of input, right? Is this what you mean? So if you mean this, that is correct, right? Because this is very much evident that if you have a code that, let's say, sorts an array, okay, now if the array size is small, it will take very less time, and if the array size is huge, it will take very large time. So one thing that all of us should know is that the run time is directly proportional to the input size. If the input size increases, then the run time also increases. Okay, that is what I mean by this statement. Okay, so I hope this must be clear to everyone. But as one of you pointed it out again, don't you think it depends upon many other parameters also? Like one of you is saying it also depends upon the system on which it is running, right? And that is correct. Why that is correct? Because think of it in this way, that there is a piece of code which you run on your personal desktop or personal laptop, okay? It might take a lot of time to run, but if you run the same code and the same input on, let's say, a supercomputer or a computer that has got multi-processors, then it is going to take very less time. So it is dependent upon the hardware also, right? So the running time of a code not just depends upon the size of input, but it also depends upon the hardware, okay, machine where your code itself is running. So these are the two important parameters out there on which it depends. So if you start talking in terms of hardware, the analysis becomes very complex. So what do the people do? People forget about hardware for a while and they assume that, hey, let's assume that all the hardwares that are out there are single core CPUs, okay. In that case, the running time will strictly be just dependent upon the input size. More the input size, more the running time, okay. So for the time complexity analysis, we will just be talking about the expression of time taken to run a code in terms of the input size. That is, if the size of input is n, let's say the size of array is n, then I should be able to express the running time as a function of n, okay. It could just be n, it could be n square plus n plus log n, or it could be anything, but it should be expressible in n, where n is the input size, okay. Cool. Now Let us take an example and try to understand that. But before that, let me tell you one more thing. When I say running time of a code, again one of you mentioned it on the chat. By runtime, what is it that I exactly mean? So I exactly mean number of operations that are happening, number of operations or number of CPU cycles, okay, that are happening. So as simple as that, if let's say there are 100 additions that are happening, now each of those 100 addition is an arithmetic operation, and who performs arithmetic operation on computer? It's CPU's responsibility, right? So for every operation there will be one cycle each. So number of cycles will be approximately 100, and you can say that the time complexity is order of 100. If number of cycles is this much, that is the total amount of number of operations, and that is what the time complexity is. So everything boils down to the fact of expressing number of operations in terms of input size. Okay, so if you have been given an array of size n, by taking a look at the code, you should be able to, yeah, that is hardware based, but I told you, right, that you have to assume it that all the systems are having same configuration. Okay, that is the reason I cut it. Okay, yeah, so you have to be able to express number of operations in terms of input size. Okay, so we'll just try to do that with a very simple example. So let's say I have an array whose size is n, okay, and I declared int sum equals to 0, int c equals to 0, and then I run a code where my I smaller than n, I plus plus, and what I am doing is sum plus equals to a of I and then c plus plus. Okay, let's say this is what I am doing. So what do you feel should be the number of operations over here in terms of input size? The input size is the size of array, which is n. So what is the number of operations happening over here in terms of input size? Those of you who are saying n, can you be a little more specific? So if you try to be a bit more specific, you can think of it like that. So first you make some declarations. Okay, now declarations that you do, you declare an array of size n. So this kind of declaration is almost order 1. I mean, it happens very quickly, instantaneously. Okay, these declarations are also order 1 each. So these are very small operations of declaration. So they will take somewhere around constant time, which I can say as order 1 time, right? Now let us take a look at this loop. So if you take a look over here, this loop will start from I equals to 0 and go until I equals to n minus 1, right? It will run till I equals to n minus 1. So how many steps are there? There are n steps, right? There are n steps, and in each step you see that 2 operations are being performed, right? In each step there are 2 additions that are getting performed. So you can say that total number of additions, by addition I mean this addition and this addition, which are happening are 2 into n. Okay, apart from that, some other additions are also happening, isn't it? That addition is of this I itself, this loop control variable, which is I, that is also undergoing I plus plus I plus plus. And how many times is it undergoing this I plus plus? It is also going that I plus plus almost order n times. So you can take into account that thing also. And for this I said that this is like order 1 only. So this is like, you can almost say that this is like 3n plus something very small. Okay, let us call this 1. 1 represents any instantaneous operation. Okay, so overall time complexity can be approximated as, not time complexity, let me not use that word, overall number of operations can be approximated as 3n plus 1, okay, where n is the size of input, right? Comparison is also happening n times, correct, comparison is also happening, so you can take that also into account. So apart from I plus plus, every time you are doing this comparison also, and this comparison would also take order 1 time for each comparison. So if you take into account that also, you will have something like 4n plus 1, right? Now when you get this kind of expression, so this is your number of operations, and people refer to this particular thing expressed as input size as the time complexity of code. Okay, so what do they do then is that there is a notion of order of expression. Okay, so this is an expression, and what is the order of an expression? Order of an expression means, let's say there is a polynomial expression in n, which is an cube plus bn square plus cn plus d. Let's say it is like this. Okay, so how is the order computed? For computation of order, it is assumed that if n is very high, okay, if n is very high, then can I say that n cube will be much higher than n square, will be much higher than n? Can I say that? I can very easily say that, right? Because let's say you take n equals to 10 raised to power 6, then 10 raised to power 18 is much higher than 10 raised to power 12 and 10 raised to power 6. So in front of n cube, this and this can be very easily ignored. So you can ignore this entire thing, you can ignore this entire thing, and this is a constant, so you can ignore this also. Now an cube, now again this a is constant, okay, so if this constant is much lesser as compared to very high value of n, then you can ignore this thing also, and then you can say that this is order n cube complexity code. Similarly for this, for very high value of n, 1 can be ignored, and for very high value of n, this constant can also be ignored. So this code has got a complexity of order n. Now what do these order expressions denote? That we'll try to understand. So it clearly denotes that let's say this code that I wrote over here, for this time complexity is order of n. So it means that if I double the input size, the time taken by the code will be doubled, and if I triple the input size, the time taken will be tripled. If I half it, the time taken will be halved. Okay, but in this case it means, what will happen if you double the input size? What will happen if you double the input size? If you double the input size, the time taken will become 8 times, right? So this is a highly inefficient kind of code, okay, because n cube is a very fast growing function, and because of that the time complexity, this kind of time complexity is considered very high. Now let us move ahead. So let's take another quick example, an easy one. So guys, whenever somebody asks you to find the time complexity of a code, the first and the only one thing that you should do is you should try to find number of operations, how many operations are happening, and you should try to express that in terms of the size of input, because once that is done, then you just have to take the order of that expression and your job is done. Okay, so even now you will do that only. So let's say I have a code like, for I equals to 0, I lesser than n, I plus plus. Let's say here my input is the number n, which determines how many times my outward loop is going to run. Okay, now let's say inside this I have for j equals 0, j is smaller than equals to I, and j plus plus, and let's say I simply print I and j. Okay, so yeah, this is the code. What do you think should be the number of operations over here? I want exact number of operations over here. Just try to keep it as exact as possible. I is starting from 0 going till n at a step of +1, and then j is starting with 0 going till I at a step of +1. So guys, what happens is, for each value of I, I'll try to compute how many times j is being changed. In other words, for a particular value of I, I'll try to see that how many times this inner loop is going to run. Okay, so let us start with the initial value of I. If I is 0, if I is 0, j will go from 0 till 0. Okay, so how many times has this internal loop run? For I equals to 0, internal loop has run just one time, because j started from 0 and finished at 0. So there is just one operation for this, right? And also you can think of this as order 1 operation. Okay, so order 1 multiplied by 1 is like 1 operation only. Now when this is over, the value of I becomes 1. For I equals to 1, j will go from 0 to 1. How many iterations will happen? 2 iterations. Okay, and every time an iteration happens, that is just of order 1. So order 2 operations here. For I equals to 2, how many operations? 3 operations. What will be the last value of I? The last value of I will be n minus 1, and for that number of operations will be n. So total number of operations will simply be the sum of these, and the sum of first n natural numbers is n into n plus 1 upon 2. So this is n squared plus n each upon 2. Now in front of very high n, this can be ignored, and again in front of very high n, this constant term can be ignored, so this would also be order of n square. Okay, so this is how you can determine the time complexity in a very easy way. Okay, cool. Now we'll try to do one more thing over here. We are going to basically learn a special kind of thing which helps us determine time complexities very easily, and not just time complexity, it speaks a lot about any new algorithm that you learn or write. Okay, and this is an equation, and this is called as recurrence equation. So let us all explore it, what it is and why is it useful. Okay, so what does the recurrence equation do? It tries to express the runtime of a code on large input. So it tries to express the runtime of a code on some large input, let's say the size of that large input is n, to the runtime of same code on some small input, let's say n. Okay, so basically what it does, let's say the time taken by a code to run on an input of size capital N, that time is t of n. Okay, similarly, if the input size is small n, let's say the time taken is t of this. Okay, now what it does, it is simply an equation which relates this thing to this thing. It could be that this thing is equals to a times of this, or this thing is equal to a time of this plus b, whatsoever it is. So this kind of equation is called as recurrence equation. Simple enough, right? I'll just try to give you one very simple example. Just read what is written on the board. It tries to express runtime of a code on large input. For example, I took large input as large n, got it? To the runtime of the same code on smaller input. Let's say that smaller input is small n. So this runtime could have been 100 milliseconds, and this runtime could have been 10 milliseconds. So it is basically nothing but an equation that relates this thing to this thing by the help of certain other constants. So let us try to build a recurrence relation for this code. Okay, we are all trying to build the recurrence relation for this code. So let me say the large input that I am taking is input n. Okay, so that will come in my left hand side, and the small input that I am taking is, let's say, n minus 1. So I am trying to relate time taken by the code to run on an input of size n with the time taken by the same code to run on an input of size n minus 1. Definitely this must be greater than this. So a plus of something should come over here. Can you tell me what should come? Tn should be equals to Tn minus 1 plus what? In context of that code which you can see written on the board. So guys, here whatever is the input size over here is 1 unit more than this. So it basically says if I increment my input size from n to n plus 1, then how many more iterations are going to happen? You just think like that. Can somebody tell me? If I increment the value of n from n to n plus 1, how many more iterations will happen? I think this is very easy to think. Just think of it like this. If I change this thing to n plus 1, is this exact scenario like this? because I have incremented my input size by 1 unit. From n I have done n plus 1. Now let's talk about this code. Okay, in this code, can I say that for I equals to 0, 1 iteration will only happen, for I equals to 1, 2 iteration will only happen, for I equals to n minus 1, n iterations will only happen, but for the last value of I, which is n, few more iterations will happen. And how many iterations will happen? N plus 1 more iterations will happen. Yeah, so did you see this thing very clearly? When you changed your input size by 1 unit, number of iterations that you are doing is equal to previous number of iterations plus n plus 1, right? And this 1 can be ignored in front of this n. So you can say that if I increment the input size by 1 unit, the number of operations get incremented by approximately order n units. Okay, so I can write this thing as Tn equals to Tn minus 1 plus order of n. So this is the recurrence relation, and now you can see it relates the two things. So what does it say? Physically it says that, hey, if you increase my input size by 1 unit, number of operations will be incremented by n units. And now you can just use this equation to derive this thing. You can use this equation itself to figure out the number of operations, which is equal to this much. It is very easy to be done, because if Tn is equals to Tn minus 1 plus order n, can I write Tn minus 1? I am just substituting n with n minus 1. If I do that, I will get Tn minus 1 equals to Tn minus 2 plus order n minus 1. I have just substituted n by n minus 1 in the previous equation, right? So in place of Tn minus 1, if you put this thing, what will you get? You will get Tn equals to Tn minus 2 plus order n minus 1 plus order n. Now the way you decompose Tn minus 1, can you decompose Tn minus 2 also? Can you do that? Yes. How can you decompose? Tn minus 2 will be Tn minus 3 plus order n minus 2, and these things will come as they were, order n minus 1 plus order n. Eventually what will happen, that this would have converted to T0, and then you will have order 1 plus order 2, so on till order n minus 1 plus order n. Is everyone clear how I decomposed it into T0 plus sum of lot many things? Now what is the meaning of T0? What is the significance of T0? What was the meaning of Tn? Tn meant that if the input size is n, how much time will be taken? So T0 means if the input size is 0, how much time will be taken? How much time will be taken if input size is 0? 0 time, right? You can just call that constant and you can just simply remove it. Okay, and then you can just do a sum of 1, 2, so on till first n natural numbers, and that will be back to n into n plus 1 by 2. So guys, these are very important things, and these play a very crucial role while trying to determine the time complexity of a recursive code. So when we will study recursion and backtracking and topics like those, it will prove very, very logical and helpful. Okay, cool. Now let's talk about, so this was a bit about time complexity. Now I'll touch upon the topic of space complexity. So here you have to be a bit careful. It's a small thing, although nothing to worry about a lot. There are two things which are being spoken about. First thing is, somebody will ask you, hey, tell me the space complexity of your code. And somebody will tell me that, hey, tell me the extra space of your code. What do you think? Are these two things the same or are they different? Space complexity of a code and extra space of a code, are they same or different? So they are slightly different. So generally some people consider it as same, and that is also not so bad, but what I am going to tell you is the technical definition of it. Technically there is a very slight difference, and try to understand it. Space complexity means overall memory that your code has utilized, and extra space means that extra memory that you have used. Extra memory means excluding the size of input. it excludes the size of input. Okay, so generally if somebody asks you about the space complexity, then he means this thing. So do not confuse yourself. Whenever somebody talks to you about space complexity, he will in general mean the second thing, which is how much extra space your code is taking. Now this is very logical, right? If let's say you are trying to sort an array, so you have a function sort that takes in an array of size n and then sorts it. So let's say you in the code that you write, you do not declare any other array of size n, you just use certain int xyz variables and get your job done of sorting. Will you tell the extra space over here is order n? Will you say that? No. Why will you not say that? Because n is the size of input, and input size is not extra space. That is a mandatory space. You cannot avoid that. But if to perform this sorting, I am taking a hypothetical case, if to perform this sorting, let's say you had been forced to create a 2D array of size n into n. In this case, how much would have been the extra space? In this case, the extra space would have been order of n square, right? Because you declared something extra, which is other than the input. Okay, so extra space is something else that you created, and space complexity technically is the overall memory consumption. But be very careful. If somebody asks you about space complexity, just make things very clear. Generally he would mean the extra space that your code is taking. Okay, so you should say that, hey, this much is the extra space. Okay, let us do a simple problem now. Let's say there is a function whose input is an integer m. Okay, and I'm going to write a piece of code. So let's say I declare I equals to 0 and j equals to 0. Now I'm going to write a piece of code. So for I smaller than m and j smaller than m. Okay, I and j were already initialized, so I did not initialize, and I will be changing them inside the code only. I'm not going to change them here. Okay, now let's look at the code. So if I see that I and j are equal, then I am doing I plus plus and setting j to 0. Else I am only doing j plus plus. This is what my code is. I want to know from you the number of operations. What is the number of operations which will happen over here? Express that in terms of m. So take your time, do not make a mistake. I would like to tell one thing very clearly over here. In interviews, generally what happens, it's a common mentality of your interviewer, whoever is sitting with you in interview. If he asks you a question and let's say you tell him a correct solution, correct algorithm, everything is fine till here. But if he asks you the time complexity of that and you tell the wrong time complexity, then that is a clear red flag. Okay, why that is a clear red flag? Because the thing that he'll make out is that you mugged it up somewhere and you did not care about even thinking about the time complexity of your code. And when you join industries, these things matter a lot, that how well your code is performing in terms of time and space and everything. So never be in a rush to give the answer, rather take your time, because these things are easy, these are simple maths. Okay, so take your time and then tell the right time complexity. Few things that I want you to wither away from your mind is it necessary that there is a code which has a nested loop? Let's say inside for loop there is another for loop. Is it necessary that the time complexity of that will be quadratic, something like order n square or order m square? Is it necessary? No, that's not necessary. So yeah, so don't make such kind of assumptions. Those are very dangerous to make. Okay, so yeah, now look at this code and tell me number of operation in terms of m. Let us try to analyze. The initial value of I and j are 0 and 0. Okay, now this code is very cleverly written. Okay, so if you take a look, for I equals to 0, how many iterations will happen? Can somebody tell me how many iterations will happen just for I equals to 0? Just for I equals to 0. Is everyone clear with that? For I equals to 0, there is just one iteration. No, not m iteration, because if you take a look over here, when your I and j both are 0 each, see, the code comes inside, it sees that I and j both are 0, and then it will change the value of I to 1 and change the value of j to 0. So for I equals to 0, there was just one iteration. So for I equals to 0, there is just one iteration, and then the code converted I to 1 and j to 0, right? Now for I equals to 1, how many iterations will be there? Just for I equals to 1, how many iterations will be there? Take a look over there. So when I is 1 and j is 0, will the code enter if, or will it enter else? It will enter else part. Okay, when it enters else part, what will it do? Will it change I? No, it will just change j. So it will convert j to 1, right? Now again, one more iteration will happen where I and j both are 1 each. In that iteration, it will hit the if condition, and via that if condition, it will convert I to 2 now and reset j to 0. So how many iterations happened? For I equals to 1, 2 iterations, right? Now for I equals to 2, how many iterations of j will happen? For I equals to 2, how many iterations of j will happen? It is easy to see now, right? For I equals to 2 and j equals to 0, when you enter inside, first you will hit the else condition, which will keep the value of I as it is and will just change j. So j becomes 1, okay? Again when it enters, again it will hit the else condition because I and j are not equal, okay? So it will keep the value of I as it is and change the value of j to 2, right? And then what will happen? Then once again when it comes inside, then it will see that I and j both are equal. So now it will change the value of I to 3 and reset the value of j to 0. So this is now order of 3. So is it not something like nested loops? It is just like nested loops where your I was 0 and j were, where your internal loop which had j in it, j was varying from 0 till I. So it's just like that internal loop has been eliminated, but the logic of if else is written in a clever way that the same thing is being mimicked, right? So for this particular value of I, how many iterations will happen? 4 iterations will happen, right? So what will be the last value of I? The last value of I will be m minus 1. So for I equals to m minus 1, number of iterations will be order m. So 1 to m, the sum from 1 till m, 1 plus 2 plus 3 plus 4 plus m will be m into m plus 1 by 2, and this is order of m square. What is the space complexity of this code? Space complexity is just order of 1 because I did not create any extra variable. There is no array, nothing. There are just few constant number of variables out there. Okay, cool. Let us move ahead now. Does everyone know about factorial? Factorial of a number n is equal to what? N into n minus 1 into n minus 2, so on till 3 into 2 into 1, right? This is what is the value of factorial of n. Okay, now tell me one thing, this n factorial, can it be written as n multiplied by n minus 1 factorial? It can be, right? Because this entire thing is nothing but this, which is factorial of n minus 1, right? Now this kind of expression is again something which is quite similar to recurrence equation that we just saw, that you are trying to relate solution to a large problem, okay, with solution to a small problem, okay. Whenever you see such kind of relations where a solution to a large problem can be derived from the solution to a smaller problem, then you can use the concept of recursion. You can write this logic in terms of the code. Now I'll tell you one thing, is this equation true for all the values of n? No. Is it true for n equals to 0? Because if you substitute n equals to 0, you will see that fact of 0 is 0 into fact of minus 1, and fact of minus 1 is undefined. Yes. So this is true only for positive value of n. And for n equals to 0, fact of n is 1, because 0 factorial is 1. Yeah. So this is how factorial of a number n is being defined. Now, an important thing over here is that this kind of thing is also called as a base condition or base case, and this kind of thing is called as recurrence equation, also called as recurrence relation. So whenever you are able to figure these two things out, you can very easily write any recursive code. Let's say you want to find factorial of a number, okay, and that number is n, okay. So one thing that you can do is, you know that fact of n is equals to n into fact of n minus 1. So you can simply return n into fact of n minus 1. But you would never want to do that, right? Cool. So while writing the code of factorial using recursion, first thing that you should write should be your base case. And your base case should be that if my n is 0, I'll simply return factorial of 0, which is 1. Otherwise, I'll return n multiplied by factorial of n minus 1. Right? What will be the time complexity over here? Okay, yeah, so n makes a lot of sense, because how can I prove it? Let's say factorial of n has been called. Now in recursion, what happens if there is a function that calls other function? Then basically there is a control switch. Control has switched from here to here. Now until unless this function returns, this function will stay. And where will it stay? It has to stay somewhere, right? Computer has to ensure that this is there in the system, because if computer forgets about fact of n, then by the time fact of n minus 1 returns, how will it switch back to fact of n? Yeah, so all of you are giving right answer. So I'll explore it a bit further ahead. So fact of n minus 1 will call fact of n minus 2. Now both of them should wait. This is waiting for this and this is waiting for this. Similarly, this will go on, and eventually you will hit fact of 0. And fact of 0 is the terminal condition. This will return the value 1. When it returns the value 1, it will return it to fact of 1, which is its parent. So this kind of thing is also called as recursion tree. So it can be thought of as a parent and a child. So there is a parent who makes calls to a child, and when the child returns something, it returns to its parent, not to its grandparent or grand-grandparent. It returns to its immediate parent and then it gets away. So you can see one thing clearly, that the function which was invoked first, that waited for the longest amount of time, and the function which was invoked in the last, that exited very fast. So whatever function was last invoked, that function was out first. Last in, first out. So whenever this kind of, have you heard of a data structure which works on this kind of principle, last in, first out principle? And what is that data structure? That is stack data structure. So because of this kind of nature of recursion, your computer system uses a stack to implement any recursive code. So what it does is, let's say initially the code that was running was of main function. So there is a stack of function calls. So currently main function is over here. Now main function made a call to factorial of n. Now factorial of n made a call to factorial of n minus 1. This made a call to n minus 2, and so on till 0. Right? So can somebody tell me what would be the maximum size of this stack? The maximum size of this stack will be order of n, because that is the height of this recursion tree. So here there is certain extra space which is in form of the stack. This is called as recursion stack or call stack, and that is order n space. So for this particular question, you are not seeing that I have declared an extra array or 2D array or vector or anything, but because I have written it a recursive code, it will have a call stack, and the size of that call stack I have been able to comment from there. So in this case, the space complexity is order n for sure. Okay, this is the order n space complexity. So from this example, I want to say whenever the code is recursive and somebody asks you about space complexity, please try to determine what will be your maximum stack size. From that you will be able to tell the space complexity. right? And about time complexity, what I can say is how many levels are there? Number of levels is order n levels are there, and at each level you see there is order 1 operation only. So like at this level you simply returned 1, returning something is order 1 operation. And now at any level, what will you do? You will simply multiply the result that you got from your child with a particular number. So there is just constant 1 multiplication, which is order 1. So at each level I can say that there is just order 1 operation which is happening. So the time complexity will also be order of n. Have faced questions that calls the recursion function is called? Yes. How to compute those? We'll help you with that in recursion topic, not right now. So you will be able to do that. Don't worry about that. When you move into recursion, you will be very easily able to figure out the size of your recursion stack and how recursion flows and everything. This was a very simple example where it was very easy to decide the size of recursion stack. But the point that I wanted to make from here was that if there is a recursive code, with respect to space complexity, be very aware, okay, that a stack will be there and your aim should be to compute the maximum size of that stack, okay. We'll teach you how to do that for any kind of recursive code, okay. Now time complexity should be simple. It should just be the number of steps which are involved in the recursion multiplied by time taken at each step, which was order 1 over here. Whether you are at the last node or intermediate nodes, you are just doing order 1 work. So this is order of n. Now as we do some really good questions on recursion, you will gain more insights into it, how to do that very effectively. So I'm going to write another code. Let's say int a equals to 0, I equals to n. Okay. Let's say while I positive, I am doing a plus equals to I, and I am doing I equals to I upon 2. Yeah, what will be the time complexity of this code? Okay, log of n base 2, and that is in a way right. See, so what is happening over here? The initial value of I was n, okay, initial value was n. Now let's see what this loop is doing. Can I say that every time the operation in loop is happening, this operation is order 1? So every time the loop executes, order 1 time will be taken, because there are 2 additions. I can approximate their time to be order 1 time, right? Now whenever a particular iteration has happened, then the size of I will become half of its initial size, right? So now n will become n by 2. After this it will become n by 2 square, then it will become n by 2 cube, and then so on and on and on. When n would have become 1, okay, then in the last step it would have become 0, because 1 upon 2 is 0, right? So this will be the total number of steps or total number of times for which my loop is going to run, right? Now how do I determine what is the height of this level? How do I determine that? So for that, what you can do is, let's say there are x steps. If there are x steps, can I say this last value, which is 1, this would be n upon 2 raised to power x? I can say it approximately. Yeah, this one will be n upon 2 raised to power x. Now if you equate n upon 2 raised to power x as 1, then the value of x that you will get will be log of n base 2. And what was this x? This x was the total number of steps, and in each step how much work I was doing? Just order 1 work. So since these many steps are there and in each step there is just order 1 unit of work, so it will just be log of n base 2 time complexity. Now if I make a slight change, if I do it like this, while I greater than equals to 0, now what will be the time complexity? Yeah, there will be infinite looping. Why? Because after 0, when you do 0 equals to 0 by 2, you will get 0, again 0, and infinite amount of zeros. So this is very deadly. So this you have to take care of. Whenever you are performing a division, you have to be very wary about this. Okay, can somebody talk to me about the recurrence equation of this? By recurrence equation, I mean, again, you trying to relate Tn to some smaller value of t. Just think what will be the recurrence equation over here. Guys, just tell me one thing over here. Let's say this is what you are seeing, right? Let me erase this. This is one ladder that you are seeing. Now tell me one thing. How much should this n change? How much should this n change so that the number of steps get incremented by at least 1 unit? How much should this n change so that number of steps get incremented by at least 1 unit? Can I say n should at least become 2n? Then only the number of steps will increment by 1 unit. That is perfectly right, guys, right? Because let's say if I change my input, if I change this to 2n, what will happen? In the first iteration, 2n will become n, and after that, whatever you will get, that will be the carbon copy of this thing. So what is happening over here? I think this is very simple to understand. Let's say you had a value of n as 8. So from 8 you will come to 4, you will come to 2, you will come to 1, you will come to 0. Okay. Now, if you consider a value like 16, you would come to 8, and then everything would be exactly same. And for all other values, I mean whether it was a value like 9, there also from 9 you directly have come to 4, and same number of operations. For 10 also same thing. So for the number of steps to get incremented by 1 unit, the input should get incremented by 2 units. Okay, so this is the thing that I wish to express. And how can I express it? If there is an input of size n, then the time taken by this will be just 1 unit more than the time taken by half its size, which is Tn equals to Tn by 2 plus order of 1. So did you see that when n became 2n, the number of steps incremented by 1 unit? When n became 2n, the number of steps incremented by 2 units. That is exactly what I have written. I am saying that if you double your input size from n by 2 to n, you will take 1 unit time more. That's it. Yeah, so the thing is, it is not always necessary to relate Tn to a value like Tn minus 1, because the relation cannot be that clean and speak out a lot. So in these kinds of cases, in certain kind of cases, you would want it to relate to some other smaller value, n by 2 or n by 3 or whatsoever is more comfortable. Okay. Can you deduce the time complexity of this code to be log n base 2 via this equation only? Can you do it? Guys, this is very easily doable, because you can write Tn by 2 as Tn by 4 plus order 1. So there will be 2 order 1s now. Then Tn by 4 can be written as Tn by 8 plus order 1. Now there will be 3 order 1s, and so on. You can decompose, and you will see that order 1 would have appeared for log n base 2 times. Okay. Let me take one last example. Just take a look at this code, and again I would say don't be in a hurry, take your time, and then tell me what will be the time complexity of this code. Do some maths, do some pen and paper work on your notebook. From there you will be able to get a clear idea of its time complexity. Stick to the basics, guys. I mean, first figure out that how many times the inner loop is running for the initial value of I, which is n. Then how many times it is running for next value of I, which is n by 2. Just try to write that expression, and then we'll all try to sum that up and figure out the final answer. Yes, do not tell me the overall expression. Can you tell me the summation that you are getting? You might be getting a series. Okay, let us do it. So see, I had told you one thing while I was talking about sieve of Eratosthenes. Do you remember it? And I believe you have made use of that knowledge to give me the unfortunately wrong answer in this case. So what did I say? That if you have a series like n plus n by 2 plus n by 3 plus n by 4 plus n by 5, what will be its summation? Order of n log n. This was what I had said, isn't it? This thing will be n log n when you are summing up the reciprocals of natural numbers multiplied with n. Guys, is it clear? Was this what I had told you? When you have this kind of series, then the sum of this will be n log n. When you replace this series by the reciprocal of primes, then what was the sum? Then it was n log n, the way it was for sieve of Eratosthenes, right? But in this case, the series that you are getting, is it something like this or is it something like sieve of Eratosthenes? Okay, let us see what we are getting. Tell me, the initial value of I is n. For I equals to n, how many times this loop will run? For I equals to n, the inner loop will run for n times, and every time constant work is getting done. So for I equals to n, order n CPU operations, right? What will be the next value of I? The next value of I will be n by 2. So for I equals to n by 2, the inner loop will run for n by 2 times. What will be the next value of I? N by 4. Then n by 8. Then n by 16. And so on and on. Is this something like this? Just broaden your eyes and see. Is this series a true copy of that? Or is it a true copy of the series that you used to get in sieve of Eratosthenes? Is it like that? No. Neither, right? So then why did you say that its answer will be n log n or n log n? Okay, you made a guess, wild guess, right? So let's take n common out, and inside you will get like this, right? Now what is your opinion about this series? Have you seen this before? Is this a geometric progression? GP, right? So this is a GP whose first term is 1, and what is the common ratio? Common ratio is half, right? Now let us take the worst case. What will be the worst case? Worst case will be that this series is very huge. Very huge series means that this is an infinite series. Do you remember the sum of an infinite GP? What was the sum of an infinite GP? It was a upon 1 minus r. First term upon 1 minus r. So if you do it, a upon 1 minus r, what will you get? You will get 2. So can I say the maximum value of this thing will be 2? Maximum value will be 2. It will never be greater than 2 because I have considered the worst case where there are infinite number of terms. Is it clear to everyone? So the maximum runtime of this algorithm will be 2 into n, which will be boiled down to order of n. So this is just an order n algorithm. Okay, and will it be order 2n? Will it ever be equal to order 2 into n? No, it will always be something which is just smaller than 2 into n, because 2 into n answer I have got when I have considered infinite number of terms. Now infinity is not a reality, right? We can take as xth step, it becomes 1 like, okay, whatsoever. Yeah, so let us do one thing over here, guys. To prove that this particular sum will never be greater than or equal to 2, I can make use of some common sense also. And let us see how I can do that. So just look at this. This is 1. Okay. Now, how much does a 1 need to become 2? 1 needs 1 more 1 to become 2, right? But it will not get 1, it will get half. Okay. Now, how much do they need to become 2? They need half to become 2, but they will not get half, they will get half of half, which is 1 by 4. Now, how much do they need to become 2? 1 by 4, but they will not get 1 by 4, they will get half of 1 by 4, which is 1 by 8. So do you see that if they are needing x quantity, they are not getting x, they are getting x by 2. So there will always be a deficit. So this thing will tend to 2. This will never become 2. This will just approach 2 from left hand side. Is that clear to everyone? So this is also another way of commenting here that this series will never become greater than or equal to 2. Okay, great. So that was all that I wanted to talk about time and space complexity. initially. So again, like this is not a closed chapter, because this is just I wanted to show you some very easy varieties that can be asked in interviews. So what was the basic thing that I stuck to? The basic thing that I stuck to simply was counting the number of operations, and that is what you should do. Just count the number of operations, that's it.